Okay, so we are going to do long division today. 3, 2 is long division and synthetic division. Today, we're going to do long division. Now, synthetic division, yes, is the short one, is the easier one, but it only works, synthetic division only works if you're dividing by something that's linear. So long division is still necessary if you divide like a cubic by a quadratic. Or, eventually here in the chapter, we're going to do asymptotes, and when you find a slant asymptote, you do long division to find that. Okay, so anyway, let's go back to elementary when you learn to divide. Alright, so what I'm doing is 645 divided by 6. Okay? So 6 is what I'm dividing by, that's the divisor. 645 is what I'm dividing, that's called the dividend. And then my answer is called the quotient. And then if you get something left over, it's called your remainder. Okay, so here's how it works. You would want to know, okay, how many 6s go into 6? 1. Okay, and then you multiply. 1 times 6 is 6. Subtract down. Long division, you subtract down. So that's 0. And you had to bring 4 down. Well, how many 6s go into 4? 0. 0 times 6 is 0. Subtract down, that's a 4. Bring down your 5. How many 6s go into 45? 7. 7 times 6 is 42. Subtract down and you get 3. There's no other terms to carry down. So you're left with 3 as a remainder. Okay. So 645 divided by 6 equals 107, and then you have a remainder of 3, so 3 out of 6 left. Okay, you have a 3/6 left. So you would write that as 107 and 1/2. Okay, you can also think of it then that 645 equals 6 times what? 6 times, what was my quotient? 107. And then my remainder was 3, so plus 3. Okay, so the same rules apply for polynomials. We're going to do kind of the same steps. Okay. So I'm doing 5x squared minus 17x minus 12 divided by x minus 4. So first of all, I check to make sure with polynomials you have to have every exponent accounted for. So you have to go in order, decreasing order. So this is squared.
Ms. Cecil,
Yes?
can I please have Susan Flower come to the counseling office?
Yes?
Thank you.
Okay, so it's 2. I'm looking at the degree here, and they have to all be accounted for. So it starts with 2, and then 1, and then constant. So I didn't skip it. If it were 3, 1, constant, I'd have to have a placeholder. I'd have to have a 0x squared there. Okay. Alright, and then the same thing for the divisor as well. This is 1 and then constant. So I would have to have a placeholder in the divisor if I needed that too. Okay, well we're good here though. I don't have to have any 0 placeholders. Alright, so I'm going to do x minus 4 is my divisor. that's what I'm dividing by. And then what I'm dividing, my dividend, is 5x squared minus 17x minus 12. Okay. So what would I want to multiply x by to get 5x squared? So basically I'm doing 5x squared divided by x, which is 5x. Okay. And when I write it up here, I'm going to line it up with its like term. So this has an x, I'm going to line it up here, 5x. So then remember, you multiply here. I'm going to put parentheses around that divisor because I have to multiply both terms. So 5x times x is 5x squared. And then 5x times negative 4 is negative 20x. Okay. When you subtract down, you have to subtract both terms. So that's going to give me 0. Okay, that's what I'm going to be wanting, is to be able to get 0 here. And then negative 17x minus negative 20x. Good, it's 3x. Okay. How many terms are in your divisor? 2. So I have to make sure I have 2 terms here. So I got 3x, but now I need to break down my negative 12 so I can have 2 terms. Okay, now we go back to the start. What do you multiply x by to get 3x? 3, and that's a positive 3, so plus 3. And now distribute 3 times x is 3x. 3 times negative 4, negative 12. Subtract down. Negative 12 minus negative 12, 0. Okay, do I have any more terms to break down? Okay, no, so this is done. So my remainder here is 0. So my solution is just 5x plus 3. That is the quotient. Okay, so 5x plus 3 is my answer. That is the quotient. Let's do another one. But then first we need to talk about our presentation of our answer. So first of all, we can have it written like a multiplication problem. So if you memorize the parts of this, then this part's not difficult. So my dividend is what you divide. So if I think about my last example, the one we just did, it was 5x squared minus 17x minus 12. So this is writing it as a multiplication problem. It says this equals my divisor, so that was x minus 4, times my quotient, so my answer, which was 5x plus 3, and then plus your remainder, which in this case was just 0. So this is writing it as a multiplication problem. We also can write it as a division problem. And if it does not tell us how to leave our answer, then this is the way we'll leave it. So you would take your dividend, so p of x, over your divisor, so you write the division problem. And that equals this, plus your remainder as a fraction of the divisor. So this would be 0 over x minus 4. But since it's just 0, the remainder part And this problem is not necessary. Okay, so what's the point of this? Is you have to know how to answer the question correctly. So proper presentation is a huge part of this. So I know all of you can memorize a process. You could do, 10 of these and be able to do them in your sleep after that. It would be, but it's more about then knowing what you're finding. Like, why are you doing it? What did you answer? You can do the process, but what does that process mean? And that part comes in on how you present your answer. Okay? So it makes sense to say that x minus 4 times 5x plus 3 equals this answer. Right? That's what you found. Okay? Okay. So we'll practice this and then we will write it both ways. You check to make sure you don't skip any exponents. So my dividend is 3, 2, 1 constant. So we're good there. And then we're good in our divisor. We'll work through this one together a little bit faster. What would you multiply x by to get x cubed? X squared. So I got to line that up with the x squared term. And then distribute that x squared, so that's x cubed minus 3x squared. Subtract down 4x squared minus negative 3x squared is 7x squared. My divisor has 2 terms, so I have to make sure I have 2 terms here. So I got to bring down my negative 3x. Now I'm back up at the top. What do I multiply x by to get 7x squared? 7x. So 7x times x is 7x squared, and then 7x times negative 3 is negative 21x. Subtract down. Okay. Negative 3 minus negative 21. 18. Okay. This is one term. I need 2 terms, so I gotta now bring down my negative 12. Okay, back up at the top. What do you multiply x by to get 18x? Okay, back up to 18. And then 18 times negative 3. Negative 54. Is that right? Okay, subtract down. Negative 12 minus negative 54, 42. Don't have any more terms to bring down. I can't go down in degrees, so I can't multiply x by something and get 42. 42 doesn't have x. So this is where I'm done. This is my remainder. Okay. So I did a long division part. Now we got to write it with this form. Dividend equals divisor times quotient plus remainder. So we're writing it as a multiplication problem. So what I divided, my dividend, x cubed plus 4x squared minus 3x minus 12 equals my divisor, x minus 3, times the quotient. So this equals x minus 3 times x squared plus 7x plus 18 plus the remainder, which is 42. Okay, now we want to write it in this form. So now we're writing it as a division problem. So you put the problem, which is this, your dividend, so x cubed plus 4x squared minus 3x minus 12. So I divided that by x minus 3. And that gave me an answer of x squared plus 7x plus 18 with a remainder of 42. So when you write it as a fraction, or when you write it as a division problem, you have to write that your remainder is a fraction of the divisor. So 42 over x minus 3. Okay, if it doesn't tell you what form to leave it in, you're going to leave it as a division problem. You're going to leave it as yes. Questions about that? Okay, we're going to be using long division quite a bit today, so I think you'll feel okay with the process when we're done, but we're doing different things with it. So this is something you should probably practice this weekend. It's been a while since you've done it, to make sure that it's sinking in, that you're understanding what you're doing. Okay, so we have this remainder theorem. Okay. And the remainder theorem tells us that when we divide by something that's a factor, like a linear factor, and we plug in that 0 into our original, then whatever value we get when we plug it in would be the same as our remainder when we divide it by its factor. Okay, so we'll look at an example. But it's saying that your remainder is equal to what you get if you plug that number into the polynomial. Okay. So it tells me the form to leave it. I want c of x, so my dividend, and then x minus c, so that's the divisor. And I need to find the quotient. So I'm going to have to divide, but we got to talk about what we're dividing. So if c is negative 2, I need the divisor. So I need x minus c. I need this part here. So x minus c, so that's x minus negative 2, which is x plus 2. So my divisor is x plus 2. That's what I'm going to be dividing by. And then I'm dividing p of x by x plus 2. Okay, make sure that your exponents don't skip 3, 2, 1 constant, so we're good here. We will do an example later today where we have to put zeros in. Okay, so take a minute, do this long division. So this is good practice of the process. should have gotten x squared minus 7x plus 3 with a remainder of 2. Questions about that? Did not get that. Okay, let's write it in this form that it wants me to. So I'm wanting to say that p of x, so x cubed minus 5x squared minus 11x plus 8 equals x minus c, which is my divisor, so x plus 2, times my quotient, so that's x squared minus 7x plus 3, plus r, so plus my remainder, which is 2. Okay, so now we're going to talk about what the remainder theorem says. So the remainder theorem says this, then that p of c equals r. So when I plug in c into p of x, I should get r. Okay, so what is c? It gives it to me at the beginning. What is c? Negative 2. Okay, so when I plug in negative 2, I'm supposed to get r. What was my r? 2. So I want to show that that's true. So I'm going to plug in negative 2 and 4x into my original. So that's negative 2 cubed minus 5 times negative 2 squared minus 11 times negative 2 plus 8. Calculate that. And that should give you 2. Okay, so if you get a remainder of 0, that means if you plug in, so it's x plus 2, so if we divided by x plus 3 and we got a remainder of 0, so that if you plugged in a negative 3, you would get 0 as your answer. That means it's a factor. That means that it is an x-intercept. You get 0. So going back to this, if you plugged in 3, because the factor is x minus 3, so if you plugged in positive 3, you would have gotten 42 as your answer. That's what the remainder theorem says. Okay, now we have the factor theorem. So we're talking about factors now. Okay, so like I just said, if when you plug in that remainder and you get 0, that means x minus c is a factor. A factor as a polynomial.
So x minus c is your divisor, like that's just what it's means.
Yeah, x minus c is just your divisor when you're thinking about the long division. So they just say c just to say that it's a constant, it's an integer. So whatever your factor is, it's the opposite of what c is.
Is it always going to be in that format, like the divisor here?
If it's a linear, if we're divided by something that's linear, yes. If we're talking about factors, then we're going to be talking about linear factors. So it is just going to be x plus a number, x minus a number. Because when you factor something, you want to factor it down to linear factors. Yeah.
Did you say that is
No, so if it is a factor, she asked about if they're x-intercepts. If it is a factor, then c, whatever that number is it is an x-intercept. It is a 0, which means that y is 0, so it's an x-intercept. Okay, so that's kind of what we're talking about here. So, we want to determine if these are factors of the polynomial. So that means if you divide, what will your remainder be? 0. Thank you. If they're factors and your remainder is 0. It's much easier once we start doing this with synthetic division, but right now we're doing long division, so we will check both with long division. Okay, so these are my divisors. So I have two different ones. I have this one, and then I have this one, and then here's my dividend. So here's what I'm dividing by, or here's what I'm dividing. So let's just start with x plus 3. Okay, take a minute to do this. Practice your long division. Remember, you're wanting to get a remainder of 0 because you're verifying that it is a factor. So if you don't, then you know you did something wrong. Before moving on to do the second factor there, just wait a minute. We're moving on. Some of you might already be done. But don't move on. Okay, so let me work and you can check as well as I go. So make sure you got that far. Okay. Okay. So was anyone not able to get that? Or do you see where you went wrong? Okay. So I got a remainder of 0, which verifies x plus 3 is a factor of 3x cubed plus 2x squared minus 19x plus 6. Now, I can take x minus 2, and I can do the same thing with x minus 2. I can check it into this as well. But then I'm still going to end up with another quadratic. And part B wants me to find the remaining factors. Part B wants me to find the remaining factors of f. So then I'd have to do some factoring after that. What I can do though, is now take this, my quotient, and make that my dividend. So I can break this down more. So I know that x plus 3 and x minus 2 are factors of this whole thing. So since I used x plus 3 already, then I know x minus 2 has to be a factor of what's remaining still. Okay, so this will just make it a little bit shorter. So I want to now check my x minus 2. And I'm making this my new dividend. Okay. So divide that. Some of you are waiting for me to do it. So I want you to try it. All right, what do we have to multiply x by to get 3x squared? 3x. So I have to line it up with this like term and then distribute. So 3x squared times x is 3x times x is 3x squared. 3x times negative 2 is negative 6x. Okay. Subtract down. So then you have to do negative 7x minus 6 minus negative 6x, which is negative 1x. This has two terms, so I have to make sure I have two terms here. What do I multiply x by to get negative x? Negative 1. So that's negative x plus 2, and there is where I get my 0. Okay, then that gives me my remaining factor. This. If it didn't equal 0, then you know you did something wrong, because it's telling me that they are factors. We're verifying. So it's kind of like proofs in geometry. You know that it's true. We're just showing why it's true.
So it says determinative, so they are. Like each.
Yes. So this does seem a little confusing because it says determinate. If it's the question stops here, then you don't know necessarily that they're factors. So if you did get a remainder, then you would say no, it's not a factor. But since it's going on to these parts, verify. This is telling us yes, they are factors, so we should get 0. But we have to show the work. And like I said, once we do synthetic division, this part will be easier. Okay, part B, it says find the remaining factors. Well, I already did that. What's my remaining factor? 3x minus 1. Part C, use your results to find the complete factorization of f. So that's asking me to write f as in factored form. So, or in this case, what's it, p? Oh, no, okay. So write this in factored form. So how many factors are there, first of all? 2. Well, it's x cubed, first of all. So how many factors do I think we have? 3. Okay. Well, a lot of you were saying 2. So what were 2 of them?
X plus 3, x plus 2.
X plus 3 and x minus 2. So what do I think that third one is then?
3x plus 1.
Yeah. Perfect. It said find the remaining factor, so 3x minus 1. So if you multiply those out, all of them, that would give you this here, 3x cubed plus 2x squared minus 19x plus 6. So this is factored form. So long division is another way of factoring. Okay. C. Find all the real zeros. So this is a little bit what we talked about yesterday, like different ways to write these things. So these are like my x minus c's here, and now I want to find the z. I want to find the 0. So that's where y is 0. So you're just setting each part equal to 0. It's just like when we solve quadratics by factoring. Okay, so that's x plus 3 equals 0, x minus 2 equals 0, 3x minus 1 equals 0. So x equals negative 3, x equals 2, and x equals positive 1/3. Okay, so those are my zeros, which are also my x-intercepts. But if I were writing it as an x-intercept, I would have to write it as an ordered pair. Okay, so you'd have to write negative 3, 0, 2, 0, 1/3, 0. Okay. Okay. We need to look at just a couple other things here. So this is one of those I told you we had to pay attention to the space holders. You have to pay attention to the exponents. So there's a lot of different exponents that would be between x to the 5th and then a constant. So you want to make sure you put all those places. And same thing for the divisor as well. So if I look at the divisor, I have x cubed, so what would be next after x cubed? X squared. There's not an x squared, so I have to put a 0x squared there as a placeholder. Okay, then after x squared, what would be next? X, so 0x, and then I can put my minus 1. Okay, then you have to do the same thing here. So I have x to the 5th. Now fill in the zeros that you're going to need for that. So I need a 0x to the 4th, a 0x to the 3rd, a 0x squared, a 0x, and then a minus 1. When you go to work this out, you make sure you're lining up your like terms. So what would you multiply x cubed by to get x to the 5th? X squared. So I have to go all the way here to put x squared. Yeah. Why is it? Yeah. It is. It is. I just wrote minus 1, but it is plus 7. Thanks. You were thinking what's that? No, they're just all minus 1. No. Okay, so that's x to the 5th, and then x squared times 0x squared is 0x to the 4th plus 0 x cubed. X squared times negative 1 is negative x squared. Okay, we'll subtract down. So zeros. 0 minus x squared is negative x squared. How many terms does this divisor have? Positive x squared. Whew. Thank you. Thank you. Okay. I think we're trying to hurry. All right. Now, how many terms does your divisor have? 4. Okay, so you can bring down this 0x, but then you also need another one. And you would need another one. And since you don't have any more, you know you're done. This is your remainder. Also, you can't go down in degrees. So you can't say that you can't multiply something by x cubed to get an x squared. So let's write this. Let's write our answer, and then we'll be done. Okay, so let's write it as our division problem. So x to the 5th plus 7 divided by x cubed minus 1 equals, well, what's my quotient? It's just x squared. And then my remainder is x squared plus 7, so you do not need to write that 0x, over your divisor, which is x cubed minus 1. Okay, tomorrow we'll do synthetic division. It'll shorten this process up. But we need long division when we're dividing by like quadratics, by things that aren't linear.